the first question, number 1. From number 1, what do we have? The first question there is that sketch the shear force and bending moment diagram and indicate principal value for the following cases. The first one is that we have to sketch the shear force diagram and bending moment diagram of a singly supported beam. Just sketch, right? While the other one is a cantilever beam loaded with a U.D.L, right? We should draw the shear force and bending moment diagram. While number 1b, we are given this loaded beam, we have to draw the shear force and bending moment diagram. But you see that 1a, you draw it in the sense that without calculation, you are drawing shear force diagram without calculation. But let's do this one first. By the time we do this one, we now go back to that one. Okay, solution. First thing first, when it comes to shear force and bending moment diagram, this is the given beam, right? Just know that anything that you are doing now, for any given question, that's what you will be doing. Nothing is changing, right? Now, we are given this loaded beam. Your first task is to apply the condition of equilibrium. And what are these conditions of equilibrium? If you check that question, question A says that calculate the support reaction, Abi, while the other one says that draw the shear force and bending moment diagram. For the first one, solution. You want to calculate the support reaction. When they say support reaction, look at this beam. Where is this beam having its support? What is holding the beam? What is carrying the beam? A and B. This arrow and this arrow, they are the support in this case. So when that question says calculate the support reaction, meaning you have to determine what the force of this support, what the magnitude of this support. Since we are having point A here and it's a vertical force or a vertical reaction, then we have RAY. RA is telling you that the reaction at A, while Y is telling you that vertical direction. Similarly, you have RBY here. So meaning to answer that first question, you need to know the value of RAY and you need to know the value of RBY, right? Then how do you go about it? You are going to apply the condition of equilibrium. And what are these conditions of equilibrium? Summation of vertical forces equals 0, summation of horizontal forces equals 0, and summation of moment about any point equals 0. Are you with me? These are the 3 conditions of equilibrium. So you are going to be applying the first one, the second one, and the third one. For the first one, let's apply the first one. Summation of vertical forces equals 0. Note, upward force is positive while downward force is negative. Are you with me? Come back to this beam. How many forces do you have there? How many? But in this case, consider your support and your load as your force. That is, identify how many support do you have? 2. What are the 2 supports? RAY and RBY, right? What about the load? How many load do you have there? Is it 1? I'm having 2. I'm having this point load. I'm having this point load 20 kilonewton and I'm having this U.D.L to be 10 kilonewton per meter. So I'm having 2 supports and 2 load. So those support and load, that's my forces. They are my vertical forces. And we said that upward force is positive while downward force is negative. Meaning RAY and RBY, they will be considered positive. Why? Because they are acting upward. While this point load and this U.D.L will be considered negative. Why? Because they are acting downward. Any question on that? It's just like you splitting it. Let's say you have something like this. This is your RAY and this is your RBY. And you have something like this. What can you say about this? Call this A, call this B. From A, it means RAY and RBY, they are acting upward, right? While B, this point load and this U.D.L, they are acting downward. So that's what we are saying. With that, applying this condition, meaning summation of vertical forces equals 0. What will I have? Positive RAY, right? So I'm saying RAY If I'm putting negative here, am I correct?
No.
Why?
Clockwise.
Because it is going upward. It is an upward force. An upward force must be what? Positive and not negative. So if I'm putting negative here, I'm wrong. Do you understand?
Yes.
So that's it. The next one will be what? When you are doing summation of vertical forces, this is the, just consider these two things. When you are doing summation of vertical forces, this is the two things you should consider. Are you with me? Now, for RAY, you are saying that RAY is going upward. That's why you have R positive RAY, right? The next one is what? RBY. Is RBY going upward or downward? If it is going upward, what will be the sign? Meaning you are saying positive RBY, right? You are done with the upward forces. Do you have a downward force?
Yes.
What is the downward force? What is the downward force in this case? 20 kilonewton and the U.D.L, right? Let's take the first one, which is 20 kilonewton. It is acting downward. It will be what? Will it be positive or negative? Negative 20. You are done with the point load. Now the U.D.L. Then considering the U.D.L, what will I have? Minus 10 kilonewton equals to what? And this is wrong. It is wrong. Putting minus 10, it is wrong. Why? What do you know about force? What do you know of force? Kilonewton or newton. In this case, what do you need for force in this case? Kilonewton. Now check. You are saying your U.D.L is your load, Abi. What do you need of U.D.L in this place? Newton per meter. Meaning you have to convert Newton per meter to kilonewton. You understand? In other words, it means you are converting your U.D.L to a point load. And how do you convert your U.D.L to a point load? The intensity in this case is what? When I say the intensity, what's the magnitude of this U.D.L? 10, right? What's the intensity? 10 kilonewton per meter. This is it here. This U.D.L. This is the magnitude of this U.D.L. Are you any question? What's the total distance this U.D.L cover? 6 meters. So you are saying the intensity times the total distance it covered. Then observe, meter can cancel meter. Then what do you have? 60 kilonewton. What you just did here, it means you converted a U.D.L to a point load. And how do you do that? You convert a U.D.L to a point load by multiplying the intensity of the U.D.L by the total distance it covered. And that's how you got 60 kilonewton. So what's supposed to be here is what? Minus 60. Any question? Are we clear? Meaning, let me recap. We said RAY is positive. That's it here. RBY is positive, right? 20 kilonewton is acting downward, minus 20. This U.D.L is also acting downward, but you converted to a point load. Why am I converting to a point load? Because from the question, the U.D.L is in Newton per meter and not in the unit of force. So you have to put it in the unit of force. That's why you converted. And how do you convert? The intensity times the total distance it's covered. And this is 60 kilonewton. And that's why we are having it here. Now, let me ask this simple question. Are we done with all the forces on this beam?
Yes.
Have I considered everything? Yes. Meaning, you can equate it to what? 0. Since we said that summation of vertical forces equals 0. Then from here, collect like 10. Make RAY and RBY the result of the formula. That is, that what? RAY plus RBY equals to what? 80 kilonewton. This and this will give us minus 80, right? Minus 80 going to the other side, we have 80 kilonewton. So this is equation 1. For the first condition of equilibrium, you've applied it, you got equation 1. What is the second condition? Summation of horizontal forces equal to what? 0. Ask yourself, is there any horizontal force here? When I say horizontal force of this nature, like this, no, right? So it means for this particular question, I'm not considering this second condition of equilibrium. Alright, what's the next condition? Summation of moments equals to what? 0. Now, what it means is that you can, anywhere you are taking your moment, the force on that point is 0. How many points do we have here? Okay, before doing this, from the given question, we are given that A to B is 6 meters, right? And we are given from A, call this place C. We are given from A to C to be 2 meters. Then C to B will be what? 4 meters. 6 minus 2, you have 4. So you are saying 4 meters. So that's it. Now, just when you want to take your moment, you always take your moment at the point where you have your reaction. Do you understand? Now, from this beam, where do I have, which point do I have my reaction? You didn't get the message. I said, when you want to take your moment, you always take your moment at the point where you have the support reaction. Now, check this beam. Where do you have your support reaction? At point A and at point B, meaning RAY and RBY. So it is your choice. You might take your moment at point A or point B, you still get the same thing. It's just what matters is your direction. Now, where should we take our moment? Point A. So if I'm taking moment about point A, indicate that's a mark on its own. Right. Taking moment about point A. Then mathematically it means summation of moment about point A equals 0. Anywhere you are taking your moment, always indicate like this, because this is a mark on its own. So from here, you are saying that you want to take your moment to point A, right? What's the force on point A? RAY. Since you are taking moment on point A, it means RAY will not be considered in your moment calculation. Your interest should be the forces you are left with. Are you with me? Now, this is this beam. This is what I'm saying, right? And we've said that we are taking moment about RAY. Since I'm taking moment about RAY, it means what's the force on RAY on A? RAY, right? It means RAY will not be considered for this moment calculation. Why? Because I'm taking moment at that point. What if I'm taking moment at point B? It means we are not considering RBY. Sure you get. So that's how it works. Know that whenever you are taking moment on a point, the force on that point, you will not consider it. You are considering all the forces aside from the one on that point. Now let's identify. Since you are not considering this one, how many forces do I have left? You know, they are what? I'm not considering this RAY now. How many forces do I have left? 3. And they are what? RBY, 20 kilonewton, and this U.D.L. Meaning RBY is going to A. This U.D.L is going to A. This point load is going to A. The question is why? Since we said we are taking moment, by definition, what is moment? Moment is the what? It is the product of force times the perpendicular distance to the turning point. In this case, A is serving as the turning point. Then every forces have their own respective distance they cover to that point. Hope you are getting it. Right? Under moment, we already know that moment is equals to force times distance. Moment is equals to force times distance, right? This is the first thing. The second one is your direction. We have the clockwise direction and we have the anti-clockwise direction. Once you know this your moment calculation very well, in bending moment calculation, you will not have any issue. You understand? So let's pay maximum attention. So for your direction, just like when you are going when you are going towards the clock direction, your normal clock at home, when you are going towards the direction, then that's clockwise. But when you are going against it, that's anti-clockwise. Just put those two things in mind. When you are going in the direction of your clock, it is what? Clockwise. Against the direction, anti-clockwise. Right? Now, back to what we were discussing. We said I'm taking moment about point A, right? Me going. What's the first force I'm seeing?
Point A.
I'm taking moment about point A now. Let's say you are going gradually. What is the first force you are seeing? 20. So you are considering 20 first. Are you with me? Now, considering 20, you already know the meaning. Moment. First times the distance. The force in this case is 20. Now, this 20 is traveling to A. Before getting to A, what's the distance it's covered? 2. Are you with me? So the moment of this force is what? 20 times 2, right? But what's the direction? It is going like this, right? Why is it clockwise? It is going in the direction of your clock, of your work clock. That's why it is clockwise. And clockwise means what? Positive. Any question? So what I am saying is that positive. Do you know why it is positive? Because it is going in the direction of your work clock. Meaning positive open bracket. What is the force in this case? 20. What is the distance? 2 meters. And why is it 2? Before you get to the point, you are taking the moment 2. The distance to get there is what? 2. Right? Moving on. You know, I said I'm going gradually. When I got to C, I saw this point load here. That's why I considered it first. Right? Going on now. What's the next force I'm seeing? Which one? I'm seeing U.D.L, right? And what? RBY. So let's take it one by one. I'm seeing a U.D.L and I'm seeing RBY. Well, let's take it what? One by one. Okay, which one should we go with first? Is it the U.D.L or RBY? RBY. Meaning RBY is traveling towards point A. In what direction? Is it anti-clockwise or clockwise? Anti-clockwise. And why is it anti-clockwise? It is going against the direction of your work clock. You know, in normal sense, your work clock, let's say this is your work clock. Your work clock can never go like this. It will come like this. You understand? You have 12, 11, 10, 9. It's not possible for your work clock going like this. Abi? Is it possible? It has to go like this. 9, 8, 7, like that. Shake it. So that's why it is anti-clockwise. So when it is anti-clockwise, meaning negative. You understand? Anti-clockwise means what? Negative. Negative open bracket. What is the force in that case? The force. It is what? RBY. Are we clear? This is it. Okay, I said that from here, we've taken the moment of this 20 kilonewton, Abi. The next one is RBY. RBY is traveling towards A. In what direction? Anti-clockwise. This is the negative. Right? The force itself is what? RBY. So you are saying RBY. What is the distance before RBY travels to point A? 6. How do you get 6? From here, it is what you are seeing. From here to here is 6. So times 6. You are done with RBY. Then don't forget, we are left with what? A U.D.L. We are left with what? A U.D.L. Now, consider your U.D.L. In what direction is your U.D.L going? Clockwise. Why is it clockwise? It is going like this. It is going like this. So, if it is clockwise, we know that it is what? Positive, right? What it means, and what do you know about movement? We said movement is what? Force times distance. So for this U.D.L, we need the force of that U.D.L. Then we need the distance of that U.D.L. Any questions? How do you get the force of that U.D.L? There are these 3 points we need to know about the U.D.L. The first one is that converting a U.D.L to a point load, simply multiply the intensity of that UDL times the distance it covered times the total distance it covered, right? That's how you get the force of a UDL. Number two, the distance of a UDL acts at the midpoint. This is a practical illustration. Now, say you have this duster, call this duster a beam. Then you now put this marker under it like this. Before this duster can be balanced on this marker, where will it be? At the what? Center. If I put it like this, will it be balanced? It can never be balanced. If I put it like this, will it be balanced? But if I put it at the center, what will happen? It will be balanced. And from the idea of centroid, you can relate it. Abi, what do you know about centroid? He said, by definition, centroid is a point in the body where the whole weight is concentrated or is acting on, right? So that's the meaning. When you have this shape, it means the centroid is at the midpoint. So that's it. So that's why just bear it in mind that for UDL, the distance of UDL acts at the midpoint. That's number two. The number 3 point of a UDL, across any length of a beam, if your UDL is loaded, let's say you have from here, let's say you have something like this. You are familiar with this, right? This is A, this is B. From A to B, let's call it 10 meter. And the intensity in this case is 5 kilonewton per meter. Call this place C. And from C, A to C, you have 2 meter. What's the first point about a UDL? What's the first point about a UDL? What do you say about UDL? I just said this now. That's the second point, the distance out at the center. What's the first point? The intensity times the distance to give us the force, Abi. The second one is that the distance out at the midpoint. Now the third point. The third point is that consider this beam A to B, right? What's the span? 10 meter. From A to C, what do you have? 2 meter. It means that this beam you can split it by saying out of this beam you can bring something like this out. Abi, are you with me? If from A to B, when you have this O beam, the intensity of this beam is the intensity of this CDO is 5 kilonewton per meter. Now, when you now bring something like this out of this, what will be the intensity of this CDO? Will it still be that 5 kilonewton or it will reduce? It will reduce. Why? Because the distance is not the same, but it will reduce. It will be the same. Meaning, for any length, if you are giving a UDL varying on the length, irrespective of the length, the distance, the intensity still remains the same. Are you getting it? From this illustration now, from this analogy, we have this. From this O beam, I can bring something like this out. Meaning from here to here is AC, which is what? 2 meter. And given that from A to B, which is 10 meter, the intensity of this CDL, the magnitude of this CDL is what? 5 kilonewton per meter. If the total distance, which is 10 meter, the intensity remains 5 kilonewton per meter. What will now be from A to C? What will be the intensity? Is it still what? Okay, this is it. If you don't know this thing, in some question, you might find it difficult. From here now, you are having this term signifies what? The distance from A to B. Abi, now say we have this A to C, which is having the distance to be 2 meter. And you already know that from A to B, the intensity of this CDL is 5 kilonewton per meter. Now from A to C, what will be the magnitude? Still 5. Why is it 5, Abi? Why is it 5? Okay, let's consider this one. Call this place D. Call this place D and call this place 3 meter. Now let's consider from here to here. I'm considering from here to D now. The A to D will be 5 meter, Abi. Sure. If I'm telling you that the intensity is still 5 kilonewton per meter, what can you deduce from here? What can you say from here? It means for your U.D.L, the intensity remains the same irrespective of the length, meaning from 0 to 2 is still 5, from 0 to 4 is still 5, from 0 to 7 is still 5, from 0 to 8.5 is still 5. Generally, given a U.D.L, the intensity remains the same across any length. That's it. Do you understand? The intensity, meaning the magnitude, remains the same. Okay, back to this question. We are taking the moment of this CDL to A, right? In what direction? Is it possible? If possible. I just check something. So from here, what the direction? In what direction is the U.D.L traveling? Clockwise. Why is it clockwise? It is going in the direction of my clock, positive. Now, as we know, moment is what? First time distance. So for this U.D.L, what we just do here, relate the first 2 points of a U.D.L or the first 2 facts of a U.D.L to this now. Meaning, I need the force of this U.D.L and I need the distance so I'll be able to get the moment. What will be the force of this U.D.L? In this case, what will be the force? 60. How do you get 60? The intensity times the total distance it's covered, right? Meaning 10 times 6. This is just the force. What about the distance? 3. How do you get 3? 1/2 times 6. And that's it. Any question? Then you can equate this to 0. From here, this one, right? 10 times 6. We just converted this U.D.L to force. This is the U.D.L. The intensity is 10 kilonewton. What's the total distance it's covered before getting to A? 6. So 10 times 6. What about the distance? From what we've explained before, we said the distance of a U.D.L acts at the midpoint. So if from here to here, since I'm considering the movement from A to B, and the distance is 6 meters, meaning this is my distance in this case, which is 6 meters. What will be the distance? Half of this 6. 1/2 times 6. That's 3. Now let's solve. It means from here, this time this will give me what? 40 minus 6 RBY minus, okay, plus what? 10 times 6 is what? 60. 60 times 3 is what? 180. Equals to what? 0. Make RBY the solution of the formula. It means that let RBY go to the other side. 40 plus 180 is equals to 6 RBY. Right? Which implies that 6 RBY is equals to this plus this will give you what? 220. Then from here, divide both sides by 6. From here, divide both sides by 6. What do you have? RBY is equals to 36.67 kilonewton. Call this equation 2, since we already have equation 1. Now, we've gotten out of the support reaction. The first question says that calculate the support reaction, and these are the support reaction. And from here, you got this equation 1 and equation 2. From equation 2, I already know how do I. Meaning, I can substitute equation 2 into what? Equation 1. Meaning, from equation 2, by doing that, I have RAY plus RBY, which is equals to 80 kilonewton. From equation 1, substitute equation 2 into equation 1. RAY plus 36.67 equals to 80 kilonewton, right? Make RAY the solution of the formula. What do you have? 80 minus 36.67, and this is what? 43.3 kilonewton. So therefore, the value of the support reaction, that is RAY and RBY, are 43.3 kilonewton and what? 36.67 kilonewton respectively. And you are done. Any question? Any question on how we calculate RA1 and RB1? No question. So once you already know those values, these two values, come back to your diagram.